Chapter 11 test. Have you guys finished all of them?
Didn't finish all of it.
Mm.
Yeah, me too.
Yeah, so any problem you wanna we spend some time?
I would probably say the last one.
Last one. You mean 19?
Yes, 19.
Yeah.
Oh. Okay, so let's duplicate it. We may go to see the answer. Anyway, let's see here. Given that the inverse of the matrix is the matrix. Oh, the matrix of this, its inverse is this, right? The second one. Solve the following system of equation. So remember, we should use the Cramer's rule. Oh, hold. Solve the following equation. Okay. So first, let's see. You say this matrix, just the coefficient of this, right? 5. Here you can think it's 0. Then 2, 2, 2, 1. Yeah, think this is 1. Then -3, 1, -1. Right? Yeah, so first you just take ln of x. Let me find. Yeah, you just take this as the variable. How about let's call it m? Then this we call it n. This we call it k, right? Then it's like our regular system of equations, linear equations, right?
Mhm.
Yeah, now you need to solve it first. I suppose there is a rule. It means, for example, if A means a matrix, time x equal to B, then both sides multiply its inverse. That means that A -1, we call its inverse of A. Yeah, if we call this is A, then this just A inverse of A, right? So both sides multiply this. So A minus B. Yeah, anyway, x just equal to A inverse multiply B. We know B is here, right? Yeah, the reason is, did you remember A inverse multiply A just equal to unit matrix, right?
Yeah, it equals to, I think it's like the 1 in matrix. Like,
Yeah, anyway,
yeah.
that's our way.
Yeah.
But I have to erase all of this to let us have space. So yeah, to save time, let me do it here. That means that use this. Oh, come on. Use this. Multiply this. Yeah, so let me write it here. Write it as 3, -1, 2. Then how to calculate this? Could you have a try?
Um,
Yeah, let me do one for you. So first row, multiply first column. Of course, here just has one column. So anyway, we'll get -3 times 3. Yeah, that means this times this. 2 times the second. Last time last. Then plus 2 times -1. Plus -4 times 2, right? Yeah, so this is the first one. Of course, I can get it. It's -9, -2. So it's -11. Then -8. So together it's -19, right? Then let me use different color. Neil, could you do this? Use this, multiply this, corresponding. Then Ray do this. Ray do this, also multiply this. So get Neil get answer here. Ray get answer here. Can you?
Mhm.
So Ray already get. Let me check. Oh yeah. So 24 plus 5, 29 plus 20. So this is correct. Neil, how about you? Do you already know the rule?
I find by
Oh. Anyway, the rule is like -1 times 3 plus 1 times -1 plus -1 times 2, right? So together we get -3, -1. So already -4. Here is -2. So totally -6, right?
yeah.
Mm. Yeah, so what's this mean? Let me erase something. Yeah, I erase here. Yeah, that means that we get LNX, LNY, LNZ. This equal to this, right? Yeah, that means that ln of x equal to -19. So x equal to e -19. Or we just write it as 1 over e 19, right? Then y equal to 1 over e 6. Z equal to e 49, right? Yeah, if we don't make a mistake, suppose it's correct. Now let's go to check answer. This is chapter 11. Where we are, chapter 11. Chapter 11, where? Yeah, 19. Where is who? Chapter 11 test. 90. Oh, yeah, it's here. Okay, you say we are right, right?
Mhm.
-19, -6. 49. Yeah, now you can screenshot this. Are you done?
Mm-hmm.
Yeah.
Yeah. Okay. Any more questions for chapter 11? Do you need we do one more? No? Okay, then we save some time because we still have a lot of contents to go through. The conic section. Okay. Here show why we call it conic section. Yeah, it's like you have cones. Then if you have section from different places, then you get several different shape, a curve. Yeah, so for example, here shows circle, ellipse, this parabola, right? Yeah, and this is a hyperbola. Yeah, anyway, they have some common properties. We call all these curves are conic section, or conic curves. Okay, suppose we already learned something, right? Like a circle and a parabola. Distance formula, equation for circle. Slope, point slope. Midpoint. Yeah, anyway. Will not spend too much time on this. Distance. Yeah, so here show distance. Yeah, by the way, this property is kind of powerful. We can try if you don't use this property. For example, I just generally write line. For example, just x minus 2y equal to 3. Then there is a point. Okay, just suppose this point is here we already have 1, 2, 3. So here let's go to 4, -4, 5. So can you get the distance from this point to this line? Who can do it? Let's have a try. So Neil do this side. Ray can write this side. Find distance. Yeah. Distance equal to what? Understand this problem?
I see the formula again.
Oh, yeah. My question is, if you don't know the formula, can you do this?
Oh, okay.
Or do this easy?
Okay, I see.
Yeah, you can. If you answer yes, then please try. If you say, oh no, I'm not so sure, or maybe it's not easy, then we can just follow the formula, right? Do you have a good way? Otherwise, I will show you the formula.
I don't think I have any way of solving this.
Uh, Neil, how do you think?
I'm not sure.
You are not sure. Yeah.
Yeah.
Anyway, what I wanna tell you is this formula is very powerful. So we would like use this. Even for this, they also write it as the standard form of the linear equation, right? Ax plus by plus c equal to 0. Then the distance just equal to a squared plus b squared, then take square root. Then x and y replaced by the coordinates of this point, right?
Yeah.
Okay, now you can use this formula. Let's say who gets the distance first. Yeah, if you get the answer right on the screen. Yeah, we need you do it fast. I already have answer. Yeah. Normally we rationalize the denominator, so it's 5,
17.
17, 5 radical over 5, right?
Mm-hmm.
Okay, good. Yeah, Neil, you can think about this later. Just follow the formula. Okay, let's keep going. Yeah, so this is very basic one. Okay, we just skip this section. Then parabola. Parabola, suppose we are familiar with it, right? Yeah, for this, maybe you can just go to exercise because we already learned this from algebra 1 or 2. It's just like a review, right? Definition, focusedness, and And let's forget this. Okay, for this, let's find one. For x line. Figure 8. Yeah, how about let's do this. 25, the figure should. Blue curve is a portion. What does this mean? This? Okay, let's do 23. In order that it's good to see the drawing, right? Oh, of course. Yeah, let's do 23. Meter. Yeah, let's have some review for the focal length and the focal ratio. We saw it just now, right? Anyway, then we come back for 23. See here. Diameter D and the vertex to focus distance P. The focal length of the reflector is the distance P from the vertex to the focus. The focal ratio is the ratio of the focal length P to the diameter. Okay. Are you guys okay with it now?
Yeah.
Then let's go to 23. Maybe I can use it. Yeah, think about how to do it. Who can tell me how to do it?
What is the 15.8 for 847?
Okay,
Does it
Probably
mean
good
the
question.
height.
Yeah, Neil, how do you think?
I think that's the height, isn't it?
Uh, yeah, you can say this is a height, but how we can use this information?
Oh,
Yeah, you can say it's the height. But anything help for us to find the focal length and the focal ratio, right? Okay, so let me tell you. It just means tell your point on this parabola, right? Then you can make use of this equation to find P. P is the focal length. So when we get P, we get the focal length. Then how about the diameter? So the diameter is just 2 times oh, 2 times 38.1, right? Yeah, that means that we have 1x equal to 30.1 square equal to 4 py. Y is, yeah, then we can get p. And we also have d, so we can get the ratio p over d, right? Then this problem done. Okay, how about you take a screenshot?
Okay. Okay, I'm done.
Okay, then let's go next section. Tangent to parabola option. Oh yeah, we'll just skip this section. It's not the core contents. Okay, then we'll do 12.4, then 12.5. Then we'll forget this, forget this, forget this. Yeah. Yeah, we'll do 2 more sections here. Ellipse. Did you guys meet with the concept of ellipse before?
Mm-hmm.
Do you know it's like its equation?
I seen it's like x over something plus y over something.
But can you write one?
Yeah, maybe.
Yeah, for example, if we suppose there is a ellipse like this, right?
Uh-huh.
It's just if take here is 4. No, I mean, sorry. Yeah, we can get its coordinate. For example, this is 4, 0. Then of course here is negative 4, 0. If here is, for example, 3, 0, negative 3, 0, right? Then
Mm-hmm.
what should be the equation?
I think it's wait a sec. Okay, it's like 16 or x plus y over 9
Mm,
equals 0.
mm,
Is
actually
it?
equal to 1,
Oh yeah,
not
1.
0.
Yeah.
Right?
I forgot that.
Yeah, anyway, you have some idea, right?
Mm-hmm.
Neil, how about you?
Yeah, I don't think I learned this before.
Oh, you didn't learn before. Okay. So, by the way, what means ellipse?
An ellipse, it's like
Yeah, we know for
a
circle, for example, circle, it means all the points to this point has a fixed distance, right?
mm,
Yeah, for example, this point, this point, the all distances are 2. So anyway, so all the point has a distance 2 to this center point. We call it a circle, right? Yeah, in order to get the equation of circle, you can make we take this center as point O, then a point we call x, y. So as the distance is 2, so we have x squared plus y squared equal to 2 squared, actually means 4. Then this is the circle's equation, right? So for ellipse, suppose this time there are 2 points. then it's all point whose distance sum to these 2 points is fixed. Yeah, if you do something, you can think you have a you have a string like this, the total distance. Normally we call the total distance is, for example, 2c. Then for this 2 point, of course you can make a coordinate system, right? Use the midpoint of this point, 2 point, if we call it, as actually we call it first, so how about we call it f1, f2. Then if the distance, I may use something. Yeah, anyway, just call this is L. Okay, it's fine. Just call it L. This string, its full length is L. Then for folks, suppose the distance between these 2 points is 2c. Is 2c. Then, excuse me. Suppose here is negative c0, right? So here is c0, right? Then we'll find all the point. Generally, we call it p, x, y, right? Yeah, as we mentioned, uh, the distance. Then this is distance 1. I call d1. This is distance 2. So per the definition, we have d1 plus d2 should be the fixed value L, right? Now how to get d1? It's x minus negative c means plus c square plus y square, right? Plus x minus c square plus y square equal to L, right? Yeah, if we go to simplify this, you get the equation of the ellipse. Anyway, maybe we have this contents on the textbook. Let's quickly go through it. Let's see. Yeah, here show. Yeah, just read the definition. The sum of whose distance from two fixed points is constant. Now let's see if they have. Yeah. Oh yeah, they call this the full distance is 2a. Anyway, then what means c? Yeah, c means the distance between f1 and f2. C is half distance of f1, f2. Then they have another constant we call b. B squared equal to a squared minus c squared. Yeah, then finally we get this. So here is the equation for ellipse. And we call it the standard form. Yeah, here is a greater than b, so it looks like this. But if b greater than a, then suppose it looks like this, right? Yeah, because this distance is b. This distance is a. Okay, here show some terms. Focal axis. Center. Vertex. Where the focal axis? V1, V2. Major axis means the number one, right? Then how to call AB? Okay, minor axis is a line segment through the center perpendicular to major axis. Yeah, for here it's a segment AB. CB, CL. Semi-minor, semi-major. Eccentricity is a ratio of C over A. Yeah, by the way, let's suppose if hold. You say here is the standard equation, right? And we have hold, B square equal to A square minus C square. Yeah, let me write B square equal to A square minus C square. So who is the largest? A, right? A is greater than or equal to B or A. B or C. Anyway, so I mean, for this ratio, we can discuss if, for example, C equal to 0, then what's this shape? Oh, no, sorry. If when C, my bad. Two cases. One case is C equal to 0, then what does this mean? Another case is if C equal to A, what does this mean? So let's say if C equal to 0, then B just equal to A, right? Then we have this go to x squared plus y squared. As A and B are the same, so we'll let it go to another side. Anyway, this means it's a circle, right? If C is 0. C is 0 actually means F1 and F2, they are a same point and just at the center, right? Okay, another case. If C equal to A, then B is 0. Then what we can get? If B is 0, then we get x squared just equal to A squared, right? Then x equal to positive negative A. In this way, it just means this circle just has one dimension, right? So this is shorter enough. Go to just like a 9, right? Or just 2 points. Yeah, that means it's not ellipse anymore. Yeah, that means that we can have, so this is a circle. If we fix these 2 points, but we can shrink this point, so let it go. When if go to here, it's like this, right? If keep going, go to here, then it's like this. If keep going, it's just go to 1, 9. So you know what I mean?
Mm-hmm.
Okay. Okay, then, oh, here may show something, right? But this is still not circle, but more close to circle than the right two. Anyway, found the equation of ellipse. Yeah, you can spend the time on the examples after class. Normally we go to do some 1 or 2 exercise. Find the distance between the foci and ellipse. Completing the square to okay, yeah, anyway, you can go through all this example yourself. Here is a property summary. Oh, this time A greater than B, right? A is corresponding to Y. So it's like this is a standing ellipse, right? So what's this mean? Found the equation is tangent to the ellipse. Yeah, we can go through this example 6. Determine the tangent line to an equation of the line tangent to this at the point. So tangent means this line and this ellipse just has one intersection, right? If it's a line like this, then no solution. If it's a line like this, then there are 2 solutions. Only the tangent line has one and only one solution. Mm. We need to. Yeah, here you may use some formula, right? But if we don't use the formula, can we solve it? Let's see. I think we can. What's this? X squared plus, oh. Yeah, just think this is a system of equation. So we take y into the equation. So we have x squared plus 3mx plus b squared equal to 57, right? That's one equation. Another equation is, of course, this line pass through the point 3, 4. So we have y is 4 equal to x is 3, so 3m plus b. Now this is a system of equation with two we have three variables m, b, and x. So suppose this is not enough. Any more condition? Oh, then of course, when x equal to let me say, when x equal to 3, this should be, it's just like this. Okay, then suppose we have to use this formula, right? Which will help us to get a square b square. Okay, but where did it mention this? Let's say, suppose in section 12.1. So let's go back to say it. Basic equation. Tangent line to a circle. Distance from point to a line. No? Where they have formula for tangent line. Did I mention this? We know the equation of the line tangent to ellipse at a point. Yeah, I suppose this is a conclusion from calculus. I just want to see where does the textbook show this? At least mention this formula. Distance. From area. Tangent line to a circle. From point to a line. Good. Do they mention this in this section? Here is the yeah, sorry, I don't know why they suddenly has this conclusion. Means that tangent line. Suppose they should give us index, right? Tangent line reflection property. They mention it here. Oh, okay, okay. Suppose it's here. Yeah. The core concept is here. Yeah, sorry we go too fast. Then they have an example. Make you make use of this formula. Right. Anyway, definition, perihelion and aphenyl is the point of the orbit at which a planet is closest. Aphenyl is the point farthest. Yeah, sometimes the exercise should mention this concept. Yeah, if you are not sure, go back to check where they mention this. Yeah, so normally the star is at one focus place. Determine distance to the sun at. Okay, we will not go through this. Now let's have some exercise. Yeah, how about we do one from here? 25 to 32. Find the equation of ellipse satisfy the given. Write the answer both in standard form and this. Hmm. Okay, how about let's choose 27. Yeah, Ray, if you know how to do it, just write it. So for left
Okay.
side, I'll do it together with Neil. Yeah, remember vertex actually means. It's like this. So here vertex 1 is negative 4, 0, 1 is 4, 0, right? So actually it's just like we know A equal to 4, right? Then this tells us eccentricity means C over A equal to 1 over 4, right? Then C is just, as A is 4, so anyway, C is 4. Oh, sorry, C is 1. A is 4, C is 1. Then our standard form is like x squared over a squared plus y squared over b squared equal to 1, right? Then can you go to get b or b squared? Yeah, just get b. Yeah, please find b. When you get it right on the screen. Yeah, let me know if you need help. For example, if you don't know the formula, I can tell you.
I probably need that.
Okay. So actually we have force is here. This we call C. This we call B. Then this is actually A. Yeah, that's why we get it from this right triangle. We have B square equal to A square minus C square, right? Then can you get B? Go to get B equal to what? So we already get it, right? So B is 15 square root. Then this equation is correct. Yeah, maybe we can have one more exercise before we take break. This time 1 to 24. Yeah, let's just find the one here. Let's see what we should do. Graph. Specify the length of the major and minor axis. The force, the eccentricity. Yeah. So by the way, let me give the formula. This means C over A. Let's do problem. Yeah, how about problem 7? Yeah, I will try. I will give you whiteboard. Yeah, let me give you the formula. You should rewrite it as x square over a square plus y square over b square equal to 1. Then you can find a and b. And c is, yeah, our formula is b square equal to a square minus c square, right? Yeah, for this case, maybe I need to change a little bit. Anyway, suppose here is B, here is A. Yeah, I think so. Yeah, go ahead, Leo Ray. Yeah, write your progress on the screen. Instead of we can say nothing.
It's kind of hard to write on the screen.
Oh, Ray, how about you?
I'm still thinking.
Okay, I suppose not so hard. Let's do it together. Both sides divide 144, right? So here go to x squared over 9. 9 you can also write as 3 squared, right? Then here go to y squared over 16 or 4 squared. Then here is 1. From this we can know b is 3. A is 4. Right? Then how about C? So we have C square equal to A square means 16 minus B square means 9. So it's 7. So C is 7 radical. Alright. So if we draw it, we suppose it's like this, right? Here is 4. Oh, sorry. Here is 0, 4. 0, -4. Here is 3, 0, -3, 0. And so the length of major axis is 8. Minor axis is 6. The force should be here, which is 0, 7 radical. 0, -7 radical, right? Then ellipse, oh, no. Eccentricity is, yeah, just here. So it's over A is 4, right? Yeah, please take a screenshot.
I'm done.
Hyperbola. To have that are not closed. Anyway, that's why we have hyperbola. See the definition. The absolute value of the difference of whose distance from two fixed points. Yeah, remember the parabola means the same equal distance to a point and to a line, right? Here means the difference of the distance is a constant. Anyway, So here show how to get the formula. Anyway, then we get this. This called standard form. B again here has b squared equal to c squared minus a squared. The important asymptote for the curve. Yeah, so it's easy to get the asymptote by yourself. You say just assume, for example, if x asymptote, if x is bigger enough, x squared over y squared. Okay, so this is a good way to get it. Then you just suppose x is approach to infinity, right? Then this square root is about x. Now here is the summary. Hyperbola standard form, like this. The foci are the points negative or positive C0, that f1p minus f2p equal to 2a. Focal axis is a line passing through the foci. The vertex hyperbola intersect the focal axis. Yeah, as mentioned here, V1, V2. The center is the midway, the transverse axis. The conjugate axis, perpendicular to transverse. Yeah, lot of concepts here. Passing through and extending our distance b. Yeah. Eccentricity, still c over a. Now this is kind of different to ellipse, right? Remember in ellipse, it's c squared equal to a squared minus b squared. So this is more like a right triangle. The c represents the hypotenuse. let me say the C is like, where is A? C is like this, right? Let me see. Oh, hold. Yeah. So this is A, this is B. Yeah, distance B. Then C is the hypotenuse. The iscenter y equal to B over A, positive or negative. Will be a hyperbola of the type showing. Okay, this time the transverse is on y-axis, right? Uh, yeah, we call the transverse. The one perpendicular to it called conjugate. So they are kind of different. C is longer than A, isn't it? Y equal to this time is A over B. 2A, 2B, C over A. Completing square to analyze the graph of hyperbola. Do you guys want to try to this? To example 2.
Oh, we could.
Yeah. You should use knowledge from algebra, right? Yeah, let's just stay here. Can you do it? I will try. Yeah, this is related with the knowledge you got from algebra. Yeah, let me know what you can get.
I got y minus 3 squared over 25 minus x minus 4 squared over 9 equals to 1.
Okay. Yeah, I get same thing as you. So y minus 3 square over 25. Even we write 25 as 5 square, right? Minus x minus 4 square over 9 right as 3 square equal to 1. So it's matched with this, right? Go here. Now, can you specify the center? So suppose, oh yeah, this time the center changed. So Ray, can you mention the place for the center?
It's 3 and 4.
Three,
Wait, no, it's
4
4
and
and 3.
3,
4
right?
and 3. 4 and 3.
Yeah,
Yes.
4 and 3. Hmm. So the graph should like this, right? Yeah, because it matches this kind of formula. Anyway, so the vertices should be related to A. So let me use a different color. So this suppose is 0. A is 5. So positive, negative 5, right? Oh, hold the vertex. No, it's not correct. We should add 4 here to the 0. Add 3 here, right? It's like translate.
Yep.
We need to translate it 4 unit right and 3 unit up. Okay, the first is, yeah, suppose we do same translate. The length of transverse axis, it's like 2a. Yeah, this like 2a. Then it means 10. The equation of the asymptote. Equation of asymptote don't, oh, but we need to move it again. Anyway, suppose before the translate, it should be found this. Y equal to positive, negative, A over B. So A is 5, B is 3, right? Then X. But we need to translate this to get X. Yeah, anyway, Y minus 3 equal to 4 positive, negative 5 over 3 X minus 4, right? Then we make sure the center is on the asymptote, correct?
Mm-hmm.
Okay. Yeah, let's see if it's correct or not. Say is this. Or should we get more? Let's see. No, they don't ask us to find the eccentricity, right? So we don't really need to see. Anyway, let's see. The asymptote is here. Okay. To identify the graph. Neil, are you okay? Any questions?
No.
Okay. Yeah, we can do one more exercise. One to 24 graph. (27 to 36). Determine the equation. Write each answer in the form. Okay. So let's just do 27. Yeah, do 27. Again, Ray, Neil. The given condition, write each answer in the form. Yeah, for problem 27, suppose the graph is like this, right? This is asymptote. Then graph like, right? So the foci is here. 4, 0, negative 4, 0. Vertex. Yeah, vertex like point here. Point here, we call it positive or negative 1, 0. Yeah, the formula should write in the form. Yeah, like x squared over a squared minus y squared over b squared equal to 1. Yeah, please try. Are you working on?
Yes.
Okay, to save time, we have to do it together. First, we know here we have c squared equal to a squared plus b squared. Then b squared should equal to c squared means 16 minus a squared means just 1, so 15. So we get the equation is like x squared over 1 minus b squared, oh no, y squared over b squared means 15 equal to 1, right? Yeah, then we almost done. Well, you can say we already done. Here the uppercase A is just 1. B is 1 over 15. C is 1, right? Yeah, so we can say this is just the answer. Okay, please screenshot.
Okay, I'm done.
Okay, Neil, how about you?
Yeah.
Okay. Yeah, then we'll not spend more time on this. For homework, for the chapter test, you can just do some basic one. For example, yeah, so 1, 2, 3. 3, you can go to try. But in order to do this, you should go back to the section. This is which section? Let me say. 12.4. Yeah, I suppose 12.4. Anyway, go to check something. Yeah, then for 6, you can do it. Equation of the hyperbola. Yeah, 9, 11. Yeah, 12, you can do it. It's related to section 12.1. Graph this, you can do it. Graph this, you can do it. Yeah, just this. Take them as the homework you can do. So let me quickly write it down. C12 test Q 1, 2, 3, 6, 9, 11, 12, 13, 14. Okay, now let's go to next chapter. Root of polynomial equation. Additional topic. Yeah, let's say division of polynomial, the remainders theorem and the factor theorem. Fundamental theorem of algebra. Rational and irrational conjugate rule. Partial, more about partial. Yeah, here show something about the division, or we call non-division. Then similar thing we can do this for polynomial divided by another polynomial. Yeah, that's what we already learned from algebra. Division. P means product equal to divisor time quotient plus remainder. Quotient and remainder. Yeah, let me just let you do a simple one. How about give you a whiteboard? When if x cube minus 1 divide x minus 1, then what you can get? Yeah, let me move this to the middle. Ooh. Okay, could you do this? And tell me the answer. Again. Leo. Ray. This is not something new. Suppose you already learned this from algebra. Ray, is this your answer?
Yes.
But check it. If so, suppose we have this multiply x minus 1 equal to this, right? But I don't think it's true, right? Means it's not correct. You can check yourself. Okay, keep it means it's not correct. You need to really go to do the non-division in order to get an answer. Neil, do you know how to do it?
Uh, I'm thinking, could you do like,
But,
wait, could you do this?
let me see. Yeah, you can keep going. If you think, let me guess. What do you mean? Yeah, I think so. Then what you can get? Then what's your answer? Yeah, it's correct.
And then you can simplify that more.
Yeah, so how do you
maybe?
call this?
No, I forgot what it's called. I think it's synthetic division.
Yeah, synthetic division. When did you learn this?
Oh, I learned it during my school year that I just had
During summer or last semester?
last semester.
Oh, okay. Yeah, that's also what we'll learn in this section. Okay, so let me tell you, Ray, you can do the non-division. Suppose this means x cube plus 0x squared plus 0x. Yeah, if we miss this term, you can just think it's x of what, right? Then minus 1. Divide x minus 1, right? Correct, Ray?
Uh-huh.
Yeah. Okay, you can try this after class. I'm gonna add Leo know this synthetic division, which is very useful to save your time. So you say here mention synthetic division. This is not good for all the case, just for this kind of case. So let me highlight this for you. Means four polynomial can be streamlined when the divisor is x minus r. This shortened version known as synthetic division. So it's the same principle as non-division, but they just simplify the writing. Mm. Mm. The basic idea is that in non-division, it's the coefficient of the various polynomials that carry all the necessary information. The coefficient can be abbreviated by writing down a sequence of four numbers. Yeah. So Ray, you can spend some time to learn this. So generally, it's the same principle, but write in different way. We can use something very simple to explain this. How about again we have the oh. Yeah, we go to something even simple. So this just called equation. This called synthetic. Oh, equation. Yeah. Well, let's do x squared minus 1 divide. Yeah, this time we use x plus 1, right? Of course, we know the answer. For the non-division, we'll do x squared plus 0 of x minus 1, right? Then divide x plus 1. Then, of course, first we get x. So here has x squared plus x, right? We do a subtract. So here is negative x, negative 1. So here is negative 1. Then negative x, negative 1. Then we done. No remainder, right? Yeah, for the synthetic division, we take it as x squared minus 1 divide. Remember, it means x minus r. So r is here is negative 1, right? Yeah, then yeah, if I write as this, actually it means x squared plus 0x minus 1 divide x minus -1, right? So now it's actually the same as this. So first, the leading term x squared minus the leading term of the divisor x. So of course we get x. Then we have x squared. Yeah, you can think it's negative. Actually, it's -1 of x, right? Then here go to -x minus 1. Then again, here go to -1. But for synthetic, we'll write this in your simple way. How? Just like -1 here. Then here x squared, its coefficient is 1, so write 1. 0 of x, so it's 0. -1, like -1. So first we'll decide as it's x squared divide x, of course we get 1. Then for the second term, we'll do this, use this, multiply this, leave it here. So -1 times 1 is -1. Then we'll do, yeah, let's have a separate line here. 0 plus -1, so still -1. Then keep going. This -1 from divisor, multiply this, then put the result here. -1, -1 is 1. Then -1 plus 1 gets 0. So our answer is, you say, this means 1 of x. This means the constant is -1. So it matches the answer, right? Now you can go to think. First we decide it's x. Then as x times -1, you get -1. So here you don't use minus, instead you use plus, like 0 plus -1, right? See here, 0 plus -1, get -1. Then again, use this -1, multiply this -1. So you get 1. So anyway, the reason they don't do this subtract, instead uh, go to uh, addition, because here we already take -1, right? Anyway, this kind of rating, we call it synthetic deviation. If you want, you can take a screenshot. This is a very simple example. But when we use this synthetic deviation to something company, though, we really save lot of time. Okay. Now let's go back here. Divide this by this. Yeah, you can go through this example yourself later on. Factorize. By divisor has form. Yeah, when x plus 1, you should think this r is negative 1. Okay, we may try 1. Mm. Yeah, by the way, they don't require the r should be whole number, right? Then suppose this still works. 32. Now let's do one. How about problem 30?
Yeah, let's do that one.
Yeah. Good. Yeah, Neil, as you already learned it, this time you can just write on your workbook. You don't need to write on screen. We'll see how Ray do it.
Okay.
Ray, I would suggest you write on screen directly. We'll see your progress immediately
Okay.
after you write. Let me see. Code. Oh, this is 1, 0. Okay, looks good. Yeah, first, because x cubed divide x, so of course you get 1. We get 1. All right. So let me say, yeah. So far this is correct. 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 Then, so what's the answer you get? So Ray, have you learned this before?
Yes.
Otherwise you learn it so fast, right?
Yeah, I have learned this before.
Oh, you have learned. Okay, now show the answer.
Wait.
Even you can say this equal to
Oh,
what?
no, I see,
Right.
I see.
Uh,
Okay, I see what's happening.
Just say this equal to what?
Wait a sec.
Mm.
Wait. Oh, yeah.
Yeah. You can say this, right?
Mhm.
Okay, good job. Okay, let's finish today's class here. Thursday will be our last class for the whole section. Okay, see you guys Thursday.
Okay, bye.
Bye.